This is a short video on inequalities and number lines. As we start, I just want to talk about number lines by themselves before we get into inequalities. We know that numbers go on forever. They don't stop anywhere. So when you're drawing a number line, it should always have arrows on either end to show that you understand that numbers just keep on going in both directions and don't stop anywhere. When I draw up my number line, I should have everything spaced out nice and evenly. So if you're going to do one, use a ruler and do straight lines. And actually set yourself up with nice, even points all the way along that you're going to draw with. So you can get there and you can put lines at each point nice and evenly along your number line. So let's look at using an inequality and a number line. A real-world situation might be something like a ride at an amusement park that says to go on this ride you have to be 4 years old or older. So that would be a ride where what we're measuring is someone's age. And we could start at 0 and have 1 and 2 and 3, 4, so on like that. And to show this on the number line, we would circle that. Now it all depends upon the wording here. If the question says 4 or older, then we would colour in that spot there to show that the number 4 is included. We're doing 4 or older. And then the rest of our number line, is shown as everything older than 4. We don't need to go all the way to the end. We can just do an arrow there. And sometimes you'll see people cover up the whole line like that. And sometimes you see just a line going above like so. But really what we should be doing is grabbing our ruler, getting it in there, and getting a nice straight line going across that way with an arrow on the end to say 4 or older, like that. If I had something that said you have to be less than a certain age, let's say less than 6 years old to go on that same ride, or a different ride, but same principle, same amusement park. So we go in and we can put our numbers in and nice and evenly mark up our number line. And 0, 1, 2, 3, 4, 5, 6, 7, and so on. Once again, what we're measuring here is age. So, you can be 5 years old, and you can be 5 and 1 day, and 5 and 2 days, and 5 and 365 days, so long as it's a leap year and you haven't turned 6 yet. It stops at 6, but it doesn't include 6 because this rule says you have to be less than 6 years old. So this time we draw our circle, but we don't colour it in. We're showing when we don't colour it in that the number 6 itself is not included. And so it's everything down there. We call this a closed circle at the 4. And we call this an open circle at the 6. Well, not everything is set up so that it goes infinitely to another end. And in reality, I suppose that our particular circumstance here it's not infinite at that end of this one, is it? You can't actually have an age below 0 for someone to be getting on a ride. So let's look at something a bit different. What if we were just told that x was a number that sits in between 3 and 7? Notice this time that I've said it's greater than but not equal to 3, and it's less than or equal to 7. So I'm going to come along to my number line and mark up the points nice and evenly. That process happens every time. Arrows go on the end. And I might have, I don't have to start at 0 on my number line. 0 could have even been in the middle depending upon what I was doing. Now, it's not equal to 3, but 3 is an important number, so I get to my 3 and I put a circle around it. It is equal to 7, so I do a closed circle at the 7. And to show that it's everything in between the 3 and the 7, I'm going to move my ruler up here and put a line that goes between the two. And so now I can see that I've got 3 is not included, but everything above 3 is included. It goes all the way up to 7 and includes 7, with the closed circle at the 7 and the open circle at the 3.